Now, imagine you're working in your garden and you have some weeds in your lawn and you want to kill your weeds. What do? We go to Bunnings, we get this selective herbicide, we go home, we spray the whole lawn. Similarly, our farmers are spraying their big paddocks with lots of herbicide every single year. So every year, we spend about $3.3 billion on weed control in Australia. Additionally, we spent $180 million on herbicide resistance. Big problem. Luckily, we have this really cool technology using computer vision that allows us to classify a weed and a crop. So in this case, we would be able to do something called spot spraying. And we also have this really cool technology developed in Australia with this autonomous tractor that is pulling a boom sprayer. Now this boom sprayer, you'll see, it's got some cameras. The cameras are classifying crop and the weeds, and then it's doing the spot spraying. You'll see the tractor in a few seconds is going to start spraying. Now this technology is amazing because we can save about 90% of chemicals. Huge, significant. However, we still have some challenges. We can only identify broadleaf species in grass-looking crops or grass-looking weeds in broadleaf-looking crops. So challenges in identifying morphologically similar species. And also the initial adoption cost is relatively high, even though it has been demonstrated that in the short term, farmers can get a good return on investment. But the main reason is because you cannot use it just yet on all crops and all weeds. So my question is, how can we accelerate the adoption of this kind of technology to reduce herbicide use in the shorter term, while this technology keeps getting better and better? So this is where something like yield can come into place. This is data collected by harvesters, and farmers are collecting this information already. So in this case, we have a yield map and areas of high yield and areas of low yield. Now, there is a correlation between the amount of weeds that you may have on your farm and the yields being produced. Okay, so potentially, in these areas where we are getting low yields, we may have a lot of weeds. However, there could be also other factors affecting yields, correct? So this could be soil type, for example. And this is where multispectral imagery can come into place. In this case, we're looking at NDVI, so looking at biomass, right? So what if we were able to actually focus on the top map? We look at those areas of low yield, and now we look at the NDVI map, and we see high biomass. This is an indication that we may have a lot of biomass, a lot of weeds, and low yields, correct? We can take another step, go farther, and then we can look at multiple years. We have different years with different types of crops. However, you can start looking at some patterns in terms of the areas in red where you tend to have these low yields. And then again, we add our multispectral imagery to try to find those anomalies where those differences are. Now, my PhD is about building a model that can combine all these different data sets to create a map like this one, where I have patches. So all my areas in red are potentially all my areas where I have weeds, and my areas in blue, the areas where I don't have weeds. Roughly, I have about 50% of the paddock that has weeds now, so this can still significantly reduce the amount of herbicides being used in the shorter term. So the general research question that I have is if I can use yield anomalies along with other data to locate weed patches in satellite imagery in Western Australia. This is the general roadmap that I'm going to have. And now in terms of the methods that I'm going to use, I'm going to explore different anomaly methods to try to create those prediction maps that I showed you before. Probably a good time to introduce Monica, who is going to be talking next about anomaly detection. She's my colleague as well, and that's possibly one of the methods that I'll also be looking into. I'm very keen to connect with people, and if you have any ideas that you think I might be able to use, or simply you would like to connect to collaborate in the future, please get in touch. Thank you very much.